QW80.
There it is.
Yeah, QW8. Everybody see that? Just look, just in the general tab, that's all the hardware associated with PLC. And that's going to tell you all the information about the hardware associated with PLC.
Okay.
Fine.
Did you throw a signal board? Oh, you did
No.
a signal board, that's fine. Would you,
AQ1,
General
general and problems.
Yeah.
On the PLC.
There you go.
You have to click on the PLC. You don't want to click on that model. You don't want to click on input, right? Just click on the PLC.
So you say the RQ80?
No. On the input, I is an input.
Sorry, so it's Q8. The output there?
Is it an output or an input?
It's saying output, 80 and 81.
So let's see.
When you click on
Okay.
analog output,
You're in Iowa. Channel 0.
Under inputs, channel 0, input and output addresses.
Oh, me.
yes.
What's the address for the analog output module?
QW80.
Yeah, QW8. So output word starting byte address is 8.
And if you include IO addresses, it tells you the rest.
Where's our what's the device that's the analog output on the trainers? It's being driven by the analog output.
Voltmeter.
Yeah, we have a meter up there, don't we? Yeah. So there's our analog output. Okay. Now that you know, just recall that the input address of channel 0, IW64, that's the information you'll need for your program, and QW80 for the output. Back to the scale. How do we get analog data into the PLC? What instruction? Yes. We always use the move instruction, right? So we're moving the physical analog data into some data file, right? Integer data file. Always use a move instruction. If we look at the scale with parameters instruction, the input, what's this input referring to? This field input? Integer file? Yeah, which comes directly from our analog input device. Our input min, what's that referring to?
Your lowest
possible value.
Yeah, the lowest possible value that transducer, that input will go to. And our input max? Yeah. And that input max is all based on, does anybody remember the specs of the analog input module, right?
Yeah.
So if we have a 0 to 10 volt transducer, and our analog module is a 0 to 10 volt analog input module, at 10 volts, we're going to see that value, right, in the PLC.
So it's not going to be the 28 number?
This is alpha.
Oh, okay.
Yeah, this is alpha. But yeah, we're going to see that 27648 in Siemens, yeah. In fact, all Siemens analog Modules, that's the spec on it.
Is that just what they're rated to?
Yeah.
Okay,
They're all
so,
10-bit, 11-bit resolution.
so that in mind, it's, Alan Bradley's more accurate with that.
Yeah.
Yeah.
Resolution wise.
Okay.
Of course, you're cutting hairs when you're down to that, that finite little detail and stuff like that. In the Siemens world, here are the instructions we use. The NormX and the ScaleX instruction. These are in the book, starting on page 159. But if you try to read this and try to figure out how to use them, it's about as clear as mud. Like a lot of the stuff there.
Seems legit.
Oh.
I said, seems legit.
So the NormX instruction, it's called that we're gonna normalize the input. The NormX instruction, it normalizes the input. What it does, it normalizes the input into some number that's understood by the PLC. It's set up just like the scale with parameters. So the value input here is coming directly from this move. All we're doing is moving channel 0 into some data file, some tag. Memory word byte 10. Whoop. You know what, I did a typo here. You see what I did?
Input word.
Yep, I didn't use this output here. When I did this, I was just throwing some stuff together. So this value input on the NormX instruction should be this MW10 transducer input.
It used to be right there.
And then we set up our min and max, just like we do in our scale with parameters. Set up the min and max. But here's the difference. So the NormX instruction, it converts this value coming in from values ranging from 0.0 to 1.0. Make a note of that. So on the output of the NormX instruction, you're going to have values from 0.0 to 1.0. The output of the NormX instruction, it's going to range from 0.0 to 1.0.
And what about input?
The input is the value input is actually right off the transducer. So at maximum input, what's the value going to be? 1.0. Yeah. At 50%, at 5 volts, let's say, yeah, it's going to be 0.5. Yeah. So you get it. And it doesn't just go to one decimal place, it goes to like 6. We actually see that, the output of that.
So we're using rounded figures?
It doesn't round, no. Unless it's gotta be doing some rounding over here, I'm guessing. But yeah. And you'll see that here in just a few minutes. Something to keep note of too, is you have to set up the data types in the instructions. So our input, it's a word, it's being addressed word level, right, because it's analog. So the data type for word level addressing has to be integer, right, 16 bits. And then since the output of this thing ranges from 0.0 to 1.0, it's got all the decimal points in there, it has to be a real. Does that make sense? Believe me, I beat my head against the wall trying to figure out how to use this stuff. And then,
The output has to be a quote-unquote real number, and then the ScaleX just a reduction.
yes, pretty much, and we'll see that. So, on the ScaleX instruction, our value input, what's our value input?
Would that be the .10 or 1.0?
Yeah, it's coming right out of the NormX instruction.
0.0, 1.0, something.
So do you have to use the actual tag, or do you put in the decimal value?
Use the actual tag, because, and here's why, just you're evaluating what's coming out of here, for the scale instruction is evaluating what's coming out of there. So this is just like setting up the front end on the SCP instruction, right? The min-max values and the input. But this other stuff here, it's being done internally on the scale parameter. If you recall, yeah. So we set up our input min, input max, here's our input. And then that little, the piece in between, the NormX and ScaleX, it's being done internally. But we also set up our scale min and max. And that's our min and max values here. So if this is a transducer, it's 100 PSI, whatever, 0 to 100. And then our scaled output over here, it's going to be in engineering units. So it's going to range from 0 to 100, or whatever we set this scale up for. Just like a scale parameter. So how do you think, so this is all for our analog input stuff, right? You remember how we did our analog output stuff with scale parameter?
You have to have another move.
With much confusion.
Well, you gotta think about it, so out of this instruction, you've gotta have raw units coming out, right? 0 to 27,648, because that's what's gonna drive the analog output module from 0 to 10 volts. So you've gotta have raw units coming out. So our min-max here will be set up from 0 to 27,648. And then our input will be the same because it's coming from here. Over here is going to be your engineering units, right? Engineering units on the input, and then raw units on the input of the scale instruction. That makes sense? Think of it this way, you've got to have raw units coming out of here to drive some analog device, right? Because this is the interface going directly to your analog output module, right?
We're gonna have to do the formula where we balance it to 0 and balance the scale in order to have the real numbers for the raw unit.
Yeah. But test question might say something like, if we have 75 PSI going into this thing, what's the output of the NormX instruction going to be? Something like that. So 75%.
Would be 0.75.
There you go.
Why is your input value your output and your output value your input?
Yeah, when I created these tags, I was kind of throwing something together.
Okay, so they're swapped.
Yeah,
Okay.
yeah. The scale, let's see, NormX output is here. Analog in, scaled input, yeah, that should be scaled output, I guess, yeah. It'll make more sense.
I didn't actually write down.
Where will you use that output? That'll go to your meter?
Yeah, yeah,
That'll be go to an output where
right.
you'll move that MW4 to the output 80.
Whatever, 75%.
Yeah, so once we get done scaling, we're gonna have 0 and 100 out here, right? And that might be used on an HMI, right? You grab this data out of the PLC with an HMI, a display object, right? that's gonna be the input to the HMI. Let's see, PIA. Go ahead and create a function and call it analog. Do a function, not a function block, just a function.